everyone, welcome to today's lesson. Today we are on Unit 2, Lesson 4. So we are on Lesson 2-4. In today's lesson, we are going to determine the domain of a function when applying composition of functions. Our language objective is to explain how to find the domain of a function when we need to do a composition. So let's take a look at today's Do Now. So for today's Do Now, we are asked to answer the following. We have been given our functions f of x and g of x, and we want to find the domain of 2 times the g function, all divided by the f function, where my input is this 6 minus 2a. Using specifically interval notation. So I'm going to make you guys pause this video, try this problem out, and let's see if our results match. Okay, so for this problem, we have twice the g function. So I input that into my numerator. I did the steps. I end up at a numerator of negative 24a plus 78. For the denominator, I am dealing with the f function, so a square root. I input my given input, which is 6 minus 2a. I distribute, I combine like terms, and I end up at the square root of negative 8a plus 19. That is all my output. Now that I have the output, I determine what I see. I see a fraction where there's a square root at the bottom for the denominator, giving us the setup of the radicand must be greater than 0. I input the radicand piece in there. I solve for a. So a quick review of what we have seen already. Now, what we are going to be looking at today is a composition. We have done problems in which we are finding the domain when we have been given some sort of input. We have seen the problems when we're looking for the domain and we have been given an operation, such as our Do Now. And today we're focused on a composition. So our thinking for today is, how do we find the domain of a function's composition? So we are looking at the domain of a composition of functions. Now, our definition, it says the domain of a composite function f composed of g of x is the set of those inputs x in the domain of f for which g of x is in the domain of f. So in simple terms, when we have a composition, we have 2 graphs that are somehow joined together, and we are looking for the domain of both graphs intersected. So in order for us to do these types of problems, there is a specific order that you want to work with. So I laid out our steps. Number 1, what we are going to do is find the domain of the input. The domain of the input is this inner function. So we are going to be dealing with the inner function and what is the domain of that inner function. The next thing we have to do is find the domain of the composition. So what we're going to do is actually perform the composition, get some output, and that output is what we're going to be looking to find the domain of. Once I do that, the last step is to put everything together. And by putting it together, what I mean is we're going to need to do some sort of quick graph to look for an intersection. It is very, very important to do step 1. So let us look at our first example, taking those 3 steps. So here we have been given the function, our f function and our g function. What we want to do is find the domain of the composition, which is f composed of g of x, using inequality notation. So I am going to do our steps. Number 1 says that we want to find the domain of the input. So in order for us to find the domain of the input, we are looking at the innermost function. In this case, g of x. So I have g of x to be 6x plus 3. So this is a nice simple one. I'm looking at that 6x plus 3, that's our output. And I'm asking myself, what is 6x plus 3? 6x plus 3 is a polynomial. And since it's a polynomial, that means that the domain would be all real numbers. All right, so I am going to leave this part as that. I did part 1, we found our domain of the input. Part 2, or step number 2, is we're going to do the composition and find the domain of that given composition. So with the composition, we start with the innermost function, which would be g of x. We take that g of x and input into the second function, which would be f, and simplify as much as possible. Okay, so here is our output, and I am going to now find the domain of that output. So that output, what case am I looking at? I'm looking at a radical piece, a square root only piece, which means that in order for us to find the domain, we need to set the radicand greater than or equal to 0. Okay, so we have a domain in which x is going to be greater than or equal to -7 over 24. The last step is to put it all together. I'm going to say PIT for short, put it together, and I am going to do my number line. So I only have one number to go by, that's that -7 over 24. So that's the only number I'm going to put on my number line. And I'm going to start shading. So the first thing I see, or the first thing we got, was the domain of the input. The domain of the input was all real numbers. So that means that every single number on this number line would be shaded in. Number 2, what we did was find the domain of the composition. And when we did that, we saw that x has to be greater than or equal to -7 over 24. So what that means is I would be including that -7 over 24, and I would be shading all these numbers that are greater than that fraction. So what we are looking for is the intersection. I clearly see that this piece here is out, is not part of my domain. So what is our domain? It says using inequality notation. Our domain would be x is greater than or equal to -7 over 24. So it turns out that that second portion, that second step, was our domain. Does not always happen that way. So it's very important to take into account that first step, and you'll see it in our next problem. So let's look at number 2. Okay, so here we have find the domain of the composition. We got f composed of g of x. It says using interval notation if our two functions are f of x and g of x. So we have been given our functions. We are going to start off the same way. I'm going to first find the domain of the input. What is our input? Our input is g of x, which in this case is 1 over x plus 1, which we have a fraction. If I have a fraction, to find the domain, I would set the denominator not equal to 0. I have the answer for part 1. I have x cannot be -1. What can x be? Every other number minus that -1. 2, we're going to find the domain of the composition. So we take that g function, input it into the f function, and try to simplify as much as possible. So there's my substitution. Now, for this problem, what we want to do is find like denominator, so I could combine that. My like denominator would be x plus 1. So I'm going to simplify this further. And I end up at the square root of -9x minus 8 divided by x plus 1. That fraction is under the entire square root. So again, make sure you understand that. It's not a fraction where the square root's at the top. Now that I have that, again, I ask myself, what is this output? Here's my output. I have a square root case. Since I have a square root case, that means to find the domain of this square root, I am going to do the radicand must be greater than or equal to 0. Your radicand is the entire fraction. So I'm going to cross multiply to simplify this. I'm going to simplify as much as possible to get my x value. And we end up at x is less than or equal to negative 8/9. You are dividing by a negative number, so just make sure you remember that rule of inequality. Now that I did step 1, step 2, the last step is to put it all together. Okay, here's my quick number line. I'm going to put that negative 1 on my number line and that negative 8/9. All right, so here is my setup. The first thing that we got from step 1 was that x cannot be negative 1. So not including negative 1, but what can x be? X can be every other number in this number line. The next thing we did was the domain of the composition. And we see that the domain of the composition says that x must be less than or equal to negative 8/9. So it can be including negative 8/9 and is all these numbers less than that. So what's part of my domain? First thing I see, again, this out piece. That is not in the intersection. So that's not part of my domain. My domain is everything to the left of that negative 8/9. So what we're going to do is actually write our domain. Our domain is using interval notation. The smallest possible x value we could have is negative infinity. And we work our way to negative 1, but negative 1 is not included. Then we start up again at negative 1 and we go all the way to negative 8/9. And that 8/9 is included, or that negative 8/9 is included. And there is my answer. Last question. So same kind of process. We have been given two functions, f of x and g of x. We are asked to find the domain of the composition using interval notation. So I am going to make you guys do step 1. What you should have got is x cannot equal 2/3. Step number 2, find the composition. So I'm going to make you guys do that as well. Find the domain of the composition. Okay, so for the domain of the composition, the first thing we're doing is the composition piece. We end up at an output of 15x minus 10 divided by negative 3x plus 6. I did the process. I needed to look at that denominator, find common denominator so I could combine them. At this point here, what we did is keep, change, flip to simplify our complex fraction. So now that I have the domain of the input, the domain of the composition, I am going to put it together. So what we have for the first piece is that x cannot equal 2/3, which means x can be every other number. For the second piece, it says x cannot equal 2, but again, what can it equal? Every other number. So what is part of my domain? Okay, so there is our domain. So if I'm looking at this graph, I'm going to see three different parts if I'm looking at it graphically. Very important is step 1, and step 3 just helps you visualize the composition's domain. So keep learning, keep growing, and I will see you in our next video.